Oh, weird. Hey, everybody. My name is Jay, and welcome back to the Azure Cosmos DB Global User Group. That was a weird introduction. I'm sorry about that. You know, live. What can I tell you? Welcome back to the Azure Cosmos DB Global User Group. My name's Jay. I come to you at least once a month, maybe sometimes more, and we talk about all the things that make up Azure Cosmos DB. We always bring in people from the community. We bring in some people who work at Microsoft. We have this amazing opportunity to learn all the different things that people are doing with Azure Cosmos DB. So that being said, if you would like to be on a future episode of this, I have a way for you to do that. You can go ahead, you can fill out this intake form. I'll get an email. I'll find out what you want to present. You can present it. Great. So I want to be able to get this moving quickly because we've got a lot to cover today and it's a really big subject. So before we do, if you did not get a chance to catch Azure Cosmos DB Conf 2025. It was about 2 weeks ago. We had a lot of great people, a lot of great conversations, a lot of great talks. I want you to take a look at this recap, and then we're going to get rolling with the show. All right.
Let's take a look back at Azure Cosmos DB Conf 2025.
Hello, everybody, and welcome to Azure Cosmos DB Conf 2025.
Hello, and welcome to our 5th annual Azure Cosmos DB conference, the conference for community by community.
Now, as I look at this game, let's take a look at how do I attach this to the team sheet.
So, Patty, what's going to happen next?
Yeah.
So executing a vector search in Cosmos DB is really simple. As I mentioned, vector search is part of our query syntax.
Messages is delivered into the change feed. In this example, I'm going to loop through every order that I received and print out some metadata for the order.
We have some social media posts here, and let's take a look at this one from Brian. He's currently following hashtag Azure Cosmos DB Conf.
If you can see the results here, now, staying inside VS Code, I was able to run this promptly.
For example, an agent needs to know about the capabilities of the other agents.
But first, let's hear how Mike Calvin, CTO of Connectify, is helping the world of gaming stay secure.
We are using Azure Cosmos DB as our operational data store, ingesting millions of transactions a day into our platform, analyzing them for suspicious activity.
So the next iteration, and the one we have today, introduces Cosmos DB. So during the development,
the most complicated part is that all these properties, they are related to each other.
And the question was, are you developing Gen AI applications with Azure Cosmos DB? And it seems like 57% of the audience at that time said yes. So
and we are using the Cosmos DB vector search capability to ask those questions. I'll quickly run through the code for you to see it.
With that, I wanted to thank you, Marco, for being an amazing co-host today.
Thank you, Patty. It's been a pleasure working with you and hosting you. So let's high five. Yay!
Thanks for being a part of Azure Cosmos DB Conf 2025.
We'll see you next year.
Thank you. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
thank you.
Thank you.
Thank you.
Thank you.
See you at Azure Cosmos DB Conf 2026. Hey, that was me. Anyway, I've got you all up to speed on what was going on with Azure Cosmos DB Conf 2025. I went ahead and I put the playlist that you can watch in our chat. There it is right there. Go ahead, watch all the videos. Great. Next, what do we have to do? We've got to do some housekeeping, and to help me do that housekeeping, I've got Askia. Hi, Askia. Thank you as always for joining me.
Hey, Jay, how are you doing?
I'm doing good.
All right. Well, yes, thank you for having me as always. And before we get started, just a couple things to go over. We posted the code of conduct in our chat. So if you can take a look at that when you get a chance. But basically what it's saying is that we seek to provide a respectful environment for all of our presenters. We definitely encourage engagement in the chat, but we ask that you please be mindful of your commentary, remain professional, and if possible, please try to remain on topic. We're going to be sharing useful links throughout the chat. There's our code of conduct. And we're going to be sharing useful links throughout the chat, so keep an eye out for that. And we want to let you know that this session is going to be recorded and will be available on demand in about 24 to 48 hours, and that can be found on the Microsoft Reactor YouTube channel. And that brings us to today's session. It's scheduled to run approximately 60 minutes. There'll be time for questions throughout. So with that, I will hand it over to Jay, who will introduce our speakers.
Thanks, Askia. I will see you at the bottom of the show. and you'll help us close out everything. So thank you.
Sounds good.
Great. So what are we talking about today? Well, we're talking about serverless. We're talking about Cosmos DB, how we can make it all fit together, and we've got some great people to help us. We've got Richa and we've got Jan. Richa, where are you? Richa, is your Jan, are you seeing her pop up in your monitor?
No, I just see an empty space. That's
Weird.
the joy of live.
Let's try that again. Strange. All right, Richa, I'm not sure why you're not coming up. Can you say hello to us? Okay. We can't hear you, see you. So why don't you go ahead, refresh, come back in. Jan and I we'll talk for a minute and see what's going on here today. Let me see. Yeah, Richa seems to be frozen. All right. Well, we're gonna have to just continue. Not really sure what's going on, but let's see. Okay. So Johan, how are things going for you today?
Hey, great. Jay, so yeah, just before we start, I just wanted to give like a quick reminder that this is a live session. So things like this might happen. And but because also this is a live session, feel free to ask any question in the chat. So we'll do our best to look at it and answer them like either during the session or at the end. We'll have plenty of time to do that, especially during the demo.
Absolutely. And your participation, everyone, is so a big part of this. We want to hear what you have to say. We want to hear your questions. You want you to ask them because there's so much that we can learn by what you might not know. That we can make sure that all the content that we create for you here on Cosmos DB global user group or just in general around the reactor, we just want to know what you don't know so that we can help you learn more. Richa, are you with us?
Hey Jay, sorry, I'm not sure what happened with my laptop out of nowhere.
Share your presentation and we'll figure it out. Worst case, you're going to be the voice behind everything.
Sure, let me just try that again.
And yeah, like Johan said, we're live, and when you do live streams, things happen. Cool. So for now, what I'm curious about, Johan, is why don't you give us a little preamble? Do you mind if I bring up the slides and maybe you can give us the intro?
Sure. So yeah, thanks for joining. During this session today, we'll explore some of the serverless options that we have on Azure that helps you accelerate your intelligence app development. And yeah, because let's face it, GenAI is only a small part of the equation, even though it's the one that gets all the attention these days. So you still need a place to store your data, some compute to run your code, and a way to connect everything together. And in the fast-paced world of AI apps development, you want to be able to iterate quickly, deploy your code without spending too much time on infrastructure management, so you can focus on what really matters, building great applications. So basically in this session, we'll cover all of these options. Richa will first tell you a bit more about what serverless is like on Azure. And then we'll dive into the code of a sample application, and we'll have plenty of time to demo you sample code with JavaScript, LangChain.js, and using, of course, Cosmos DB to support our workflow.
Got it. All right. Well, I don't know what's going on with Richa right now. So, Jan, I might need you to go ahead and take over.
Sure. Oh, Richa is there.
Richa, there you are. Welcome back.
Yeah. Thanks, Jay. Thanks, Johan, for stepping up. I am still facing some issue with my laptop, so you please go ahead and share the presentation. I'll do the. I'll just go over the talk.
Sure. So, okay, let's move, and I'll give you the space. Just let me know when you need a change of slide.
Sure. Thanks. Hey everyone, this is Richa Gaur. Sorry about the mishap from my side. I don't know, sometimes internet connectivity takes a hit. So yeah, thanks Johan for the introduction. I want to start with a simple yet powerful idea. What if developers didn't have to worry about servers at all? Serverless is not about no servers, it is about developers not managing them. Developers write code, deploy it, and platform takes care of the rest, from provisioning, scaling, to even fault tolerance. Serverless offers full abstraction of servers. Developers can stay focused on writing code, writing business logic, and not managing VMs or load balancers for that matter. All that complexity is abstracted away by the cloud platforms. Serverless offers instant event-driven scalability, which means resources can scale up according to events. It can scale up from 10 users to 10 million users all in real time without you having to worry about the scale. And finally, this one is my favorite, pay per use. You have to, you only pay for the time your code executes, not uptime, not idle capacity, just pure execution. Think of it as like Uber. You get to ride in the car without owning the car, but you pay for the right times. Serverless is exactly that. Next slide, please. Now, why is serverless exciting for developers? There are three main reasons, in my opinion. First one is flexibility. Serverless unlocks agile experimentation. You can quickly pivot, scale slowly or fast according to your requirements, and you can adapt to microservices incrementally. There is no need to bet the farm on day one with serverless. You can grow according to your requirements with agility. Serverless lets you focus on what matters, writing business logic, solving business problems, not managing infrastructure. And finally, with serverless, you ship faster, you are efficient, your fixed infrastructure cost becomes variable, and you waste less, both in resources as well as engineering time. Serverless architecture are naturally more robust because cloud takes care of fault tolerance out of the box for you. Next. Yeah. At the heart of serverless is a programming model called FaaS, or function as a service. It basically think of your breaking your application into small bite-size tasks. Each of these tasks has a single responsibility. Basically, each task has single responsibility. It does one thing well. You can compare the task to functions. So basically, task is synonymous with function. That's where function, the concept of function and the model of functions come in. So each function has a single responsibility. It does one thing very well. It is short-lived. It starts, it executes, and it exits. It doesn't stay idle. And it is stateless. There is no memory management required. There is no memory for the past. So you have to write code for stateless application. And finally, it is event-driven. It is triggered by events like file uploads or database inserts or queue messages. So this model is basically beautiful and beautifully decoupled and massively scalable if you think about it. You write code in small units. You wire them up to events, different kind of events, and cloud takes care of the execution. Azure's take on FaaS is Azure Functions. It's a powerful and flexible event-driven compute platform. Azure Functions provides integrated programming model. You can use triggers and bindings, input and output bindings, to connect to cloud services like storage, HTTP calls, Cosmos DB, or queue messages. It can be anything. So there are it has a rich set of triggers and bindings to connect with a wide variety of cloud services with very minimal code. It offers enhanced developer experience. It lets you write your code in your familiar environment, in your local environment using VS Code or even an Azure portal. And you can debug your code in your familiar environment without having to learn a new technology or IDE for that matter. With durable functions, you can even manage complex workflows without managing the state yourself. And there is a wide variety of hosting flexibility. With Azure Functions, you can start with something lightweight and go up to enterprise scale. And Azure Function will handle the deployment for you at every scale in between. Now, this is where it gets exciting. Azure Functions meets serverless. So with its existing superpowers on the left, you have scalable ingestion, you have wide variety of triggers and bindings, you have compute for function calling, and durable functions for managing complex orchestrations. And on the right, this is where you get all superpowers for AI. With Azure OpenAI's extension on functions, you get bindings and triggers for scaling assistance. So you can basically call different functions based on user prompts, chat completions, embeddings, and everything in between. So with this, you have with this capability, the Azure Functions let you trigger an LLM or be triggered by a LLM with very minimal code. So you have all the bindings and triggers in place, and that just kicks in with one line of code, and you have everything ready on your with your code. And excitedly, this is already in public preview for you to try and play with. Serverless compute needs serverless data, and this is where Azure Cosmos DB Serverless comes into the picture. It is a database with AI, which is built for AI and event-driven apps. Its superpowers are massively scalable, flexible, and basically rich set of developer programming models with a wide variety of SDK supports. With serverless, you are very cost efficient. You only pay for a request that you execute. It can be as cheap as 25 cents for 1 million request units, which is, if you think about it, it is massive. You are only paying 25 cents. And you only pay for what you use. So there is no idle capacity or provisioning required. So you can start very simply. There is no provisioning, no capacity management. You just create a serverless database, and that's it. You start executing your request. You don't have to think about VMs. You don't have to think about coarse memories, request units, anything for that matter. And it is great for unpredictable workload, multi-tenant systems, and even dev test environments. With Azure Cosmos DB, along with Azure Function, it forms a fully scalable serverless backend from ingest to logic to storage. And this is where it gets exciting for Cosmos DB. If you, I don't know how many of you are already aware or not, but AI needs semantic searching. And this semantic searching is supported with vector search. Now, vector search is a technology where you create vector embeddings to find similar data using vector indexes. So Cosmos DB offers Disk ANN, which is a cutting-edge technology developed by Microsoft Research, and all Microsoft products are powered by it, whether it is Bing Search, Outlook Search, SharePoint, or Teams. And now this cutting-edge technology is being brought to you as customers by my Azure Cosmos DB. where you can query your data using vector search with DiskKNN. DiskKNN is powerful because it lets you, it basically stores the data. It First of all, it basically compresses or data. Am I audible?
Yes, we can still hear you, Richa.
Yeah, sorry. Yeah, I think my screen froze for a moment. Yeah, DiskKNN is special because it performs fast and flexible vector search. And how it does that, it basically uses a quantization method to compress vectors into memory, and it has a full fidelity graph on the disk, which lets you uh, uh, perform vector search on a high magnitude, basically large data set, while keeping high performance and low latency at the same time. So the way it works is, like, when you query your data, first query the in-memory index, and it has pointers to the full fidelity graph in the SSD. So this basically lets you grab all the nearest neighbors with high accuracy while maintaining performance, unlike HNSW, which with which the performance degrades over time, as many insertion upserts and deletions happen. So this can preserves the performance and accuracy over a large data set compared to other in-memory algorithms. So basically, the capability of vector search with DiskKNN allows Cosmos DB to unlock a wide variety of AI use cases. Yeah. So basically, you can combine operational and vector database in the same database. So this not only unifies your the transactional data, operational data, and vector embeddings together. It basically combines the power of querying engines with the traditional transactional queries involving equal range of special filters like queries, along with vector search in the same query, which drastically reduces the complexity of the application, with no ETLs involved, no different querying engines and components involved, as well as reduces the cost at the same time, while allowing the optimized developer experience for which Cosmos DB is built. On top of this, you have RAG, which allows you to feed LLM the relevant data from the context that you want to provide with. So you can develop RAG-based application on Cosmos DB by providing the context from Cosmos DB data itself. It is way cheaper than fine tuning, and you can iterate way faster using RAG as compared to fine tuning. Coming to conversational history, you can store chat history in Cosmos DB. It provides conversational context to the LLM as well as the user, thus improving user experience and maintaining the continuity of the conversation. On top of this, you get semantic caching. With semantic caching, you can reduce the LLM token consumption, which reduces cost of using LLM. And you get response latency faster with smart intent-based caching. And finally, AI agents. You can handle agent-to-agent conversation with stateful Cosmos DB as the memory backend. So from a standpoint, if you look at it, whether it's Gen AI or chatbots or even intelligent agent, Cosmos DB brings performance, scalability, and simplicity to your AI applications by combining the power of operational transactional queries as well as vector search at the same time. Yeah, lastly, I would like to draw your attention towards ChatGPT. I'm sure all of us here would have used ChatGPT OpenAI's ChatGPT is the world's fastest growing application, and with its exponential growth rate, it faced numerous challenges during scaling, and that's why it moved away from Postgres SQL to Cosmos DB to mitigate those challenges. With Cosmos DB, it has been able to scale from few partitions to 40,000 plus partitions seamlessly with zero downtime. And now it runs a whooping 19 billion daily transaction without any hitches and glitches whatsoever on Cosmos DB. So if this basically, provides a testament to Cosmos DB's scalability and simplicity in terms of scale and growth. And if ChatGPT can do it on Cosmos DB, so definitely you can as well. So I think now we have enough context about different serverless technologies and their out-of-the-box capabilities when it comes to developing AI application on serverless technology, whether it is compute using Azure Functions or using vector search with Azure Cosmos DB, powering all the data search required for AI applications. So now we'll move to showcasing a demo where you can see a live demo of how a serverless application is built using Cosmos DB, Azure Functions, and other serverless technology to power a LLM-based chat agent. I'm handing it over to Johan now. Thank you.
Thank you, Richa. Just looking at the chat quickly to see if we have any question. Yeah, if you want to ask anything, just put your comment in the chat and we'll take a look at it. So now going on with the demo. Before I forget, let me just copy paste the link in the chat so you can take a look at the repo if you want. So it will also be available at the end if you need it. So yeah, we'll be sharing that. So moving on to the repo. Yes, first let's have a look at the GitHub. So this sample application that we'll demo today, you can access it using the link I shared. It's on GitHub and it's fully open source. So basically, we've built an AI chat, just something like your regular ChatGPT application, all using serverless technologies and using the LangChain.js framework. So under the hood, we've taken the use case of a support chatbot for this console real estate application. So basically, it can answer questions using Retrieval-Augmented Generation about any kind of support you may need, whether it's using the website, like booking rentals, or asking about refund and stuff like that. It's all based on documents. Since it seems that there's an issue with me, I cannot share it on the chat. So maybe someone from the staff, maybe Jay, you have the rights to share a link. It seems that I cannot, so I will be quickly showing the URL here in the slides, just so you can have the time to grab it. So it's aka.ms/ai/js/chat. Yes, thanks you. So yeah, this application will dive a bit deeper just after, but let me start with a quick demo so you can have a better look at what we are talking about. So we have this support chatbot. Here you have some example question that you can ask, like for example, how can I do like a search if I want to do some to book a rental? So here I get like a step-by-step answer from the knowledge base. And you can see something important is it's not just a straight answer from the LLM. It's based on documents that we provided that were ingested into a Cosmos DB database. So you can see that this particular answer was built using these two documents. So I can click on it. If I want to have like a quick look at the full, this is the terms of service document, so I can have a look at all the details if I need. So this is very important because this sets a ground flow for your customers. So basically they can have more trust in any of your answers to see what's behind what the LLM generated. So you can see also that it generated like some follow-up questions, like for example, is it possible to book a rental without an account? So yeah. Something also interesting is that to build this, we use the vector search capabilities of Cosmos DB to implement a RAG pipeline. But we've also implemented something that's also, again, very similar to what you can see in ChatGPT, an history of all your chat sessions. So it's easy to go back in time and maybe resume any of your past session. And you can also see that it has like a very handful summary of each of these sessions. And this is built using the regular storage capabilities of Cosmos DB because it can act both as a regular database for your data workload and both as a vector search capable database for like use case like we're using here using RAG. So let's dive in a bit into like the technical details. So for this use case, what we wanted to do is showcase like a possibility of you to get like a starter project where you can use your own data. So it's very easy if you look at the repository. You'll see that there is a data folder with some PDF in there. So this is the documents that we're using in our chatbot to answer any of the question. But you can very easily replace this document with your own PDFs if you want to test it using your own data with your own use case. So yeah, I've already said that. The use case is a support chatbot for this content store real estate enterprise. And yeah, if you want to give the demo a test drive, knows that you can start it without deploying anything first because it's able to run fully locally using Olyama. If you have installed that on your machine, we can use like local models to generate like the embeddings, the vectors from the PDF documents, and to generate the answers. Of course, it won't be as good as using like the online LLMs, but it's already good to do a quick test of the application to see if it can support your use case before deploying it and testing it on a fully deployed version. And also, just knows that we've built this sample just not as a quick demo, but we've built in with enterprise-grade security in mind. We don't use any API keys throughout the demo, so I can even show you my .env file with everything in it because there's no API keys. We're using fully managed identity with enterprise-grade security throughout all the whole sample. So it's really meant to be used as a starter for your own project. So I see a question in the chat. So from Guillaume, each time a user sends a prompt, the LLM has to load and read this PDF. So no, I can just do a quick answer to this question. So when it's time, basically the RAG process works in two stages. The first stage is that right after we deploy the application, there is an ingestion phase where we upload basically the PDF to the API to segment the PDF into smaller chunks of text and transform them into vectors to put them into the database. So when we're asking a question, we don't need to read through like all the PDF and run through that process because it has been done ahead of time. So what we are doing when we're trying to answer a question is basically just do a vector search in Cosmos DB, which will like surface the most relevant documents to answer that particular question, and then we inject the small chunks of text that are useful to answer that particular question to the LLM. So that's basically how Retrieval-Augmented Generation works. So now, from a technical standpoint, we're using many of the services that Richa introduced in the beginning. So first, we have this client application, so the chat UI that you've seen in the demo. This is hosted in a Static Web Apps. So this is a just plain HTML and JavaScript web application. And all the core of this application is handled into a serverless API hosted on Azure Functions. So the ingestion process, as I said, is basically we have an API where you upload your PDF, and this PDF will be sent and transformed as vector into Cosmos DB using an embedding models using Azure OpenAI service. And we're also saving this PDF just so we can link back to them later using a blob storage. So we store like the original PDF files just as part of the ingestion process. And then when we want to answer any question from the user, again, using HTTP call, we're going through our serverless API, basically doing a vector search on our knowledge base, and then using a chat model, it's GPT 4.1 in that case, using Azure OpenAI service to basically build the answer. And as you've seen, we've also introduced the chat history feature. So once you get your first answer, basically for every new message that we have in the chat, we're generating a title summary for the chat session and store the session and retrieve them. If you click, like, for example, on the history panel, retrieve the chat session directly from Cosmos DB. So this is all our components, so all serverless technologies to build our application. Now for the technical stack, our backend is built with Node.js. All our source code is using TypeScript, and for our AI orchestrator, we're using LangChain.js. And you'll see that we've built LangChain.js is an open source framework, so it's free to use, and it can both use. It's very easy to use both local components and cloud components, and like compare providers if you want to. And you'll see that we have all sorts of Azure integration for everything that you need, whether it's like the vector search, the chat model, the embeddings, or even the chat history. Everything is already like fully integrated into LangChain.js. And our serverless API is hosted on Azure Functions. Now for the front end, our front end is very built using a simple stack. So we have basically two web components that were built using the lead framework. We have the chat component and an history component, just to show you the history panel on the left, the one you've seen in the demo. And we just integrated these two web components into like a very simple HTML web page. And we built and test the app locally using the Vid bundler. So once we have built this application, it's deployed, the front-end part is deployed on Azure Static Web App. So now let's dive a bit into the code of the sample, so you can like try to clone it into your own machine and try to use it. So you see that this project is built as a monorepo. So we have two main components, the serverless API and the web app. So under the package folder, you have all the PDF data, the one that you can see, it's the same, or I can show you it directly in VS Code, but you can open it in your browser or any PDF reader to see. It's basically the same thing that I've shown you like in the demo. You can replace them with your own use case if you want. We also have like a full tutorial under the docs folder if you want like to dive into like the different part of the sample. And it's very easy also to deploy this sample. Because we provide full infrastructure as code in the infra folder, and to deploy it, if you have like the Azure developer CLI, basically you only need to run one command. Once you have installed the AZD CLI, you just do AZD up, and it will provision everything that you need for this project. And because it's using serverless technology, you only pay by the usage. So meaning just deploying this application to test it and deleting it after won't even cost you like maybe a few cents at worst. So now diving into the code. So the most interesting part is the API. So you can find it into like API SRC folder, and you can see all our functions that we have in there. And maybe we'll start with the like most complex one, the chat post one. So this is what basically happens when a question is sent to the API. So let's start with the beginning. So I say that we were using LangChain.js. So you can see all sorts of integration that we have for Azure. For example, for Azure OpenAI, we have like the chat model and the embeddings in there. We have the components for using Cosmos DB into LangChain, like the chat message history component and the vector store component that is able to do like the vector search part of our RAG pipeline. And yeah, we can see our system prompt in there. So yeah, we just say that the assistant helps Continental real estate customers with question and support requests. We say a few things about how to format the answer. And because it's RAG and we wanted to show to be able to show the sources, we have part of the prompt to say, hey, since you will be using excerpts from PDF documents, always mention the source file that you're using. So that's why we're able to show this source link into the answers. There's also the parts for the follow-up questions. And that's basically it. So for simplicity reasons, we've put everything into the same prompt. But if you're looking to use maybe smaller models and if you want to optimize, you can get better performance by doing like these three parts using separate API calls. But just for simplicity, know that it also works if you do it all in one go. And this is also for the history part, because we want to be able to save a chat session and have like a small title summary for each of our chat session. We also have a very small prompt to generate this title based on a chat session. So now let's see what happens when an HTTP call hits the API to get an answer. So to be able to do this, we need 4 LangChain components to do that. We need embeddings, we need a chat model, we need a vector store. So this is our vector database, and we need something where we can save the chat history. I said that just in the introduction, we've made all our APIs for this project to be able to run both when deployed on Azure, but also locally. So we have, for every API, we have these 2 use cases. Either you're using Azure, and then in that case, we're instantiating the Azure components using the LangChain integration for Azure. So like in this case, the embeddings, the chat model, and our Cosmos DB vector store. So as you can see, it's quite easy. Same for the chat history. Or if you want just to test the application running locally without any deployments, we can do the same thing instead using like Oliama components and a local vector storage and just a simple file system history. So once we have our components, basically it's the same thing whether you're running locally or in the cloud, thanks to like the LangChain abstractions. So we're creating our chain. So the concept of chain is basically the same as if you're saying a workflow. So we have this function, create stuff documents chain, to say that we're doing RAG. So we're just passing in our model, our prompt, to say, okay, this is our system prompt that I've shown you in the beginning. And this is the input that will be injecting the question from the user. And this is how the source document will be formatted and injected into the prompt. So the LLMs will be able to take that information and format it into a proper answer. So this is the first component of our chain. And we also want to handle chat history. So LangChain, if we inject an history component, it will be able to do that automatically. Just saying, basically, we're adding an history as part of the chain, saying, okay, it will inject that using this key. And this is how we get the chat history component that we just instantiated here using Cosmos DB just earlier. So, okay, we're instantiating the chat history. And then we're doing the RAG process. So the RAG process, first, we're doing transforming our vector store into what we call the retriever components. So basically a component that will do a vector search and return the top 3 matching documents that we have in the database, matching the topic that's relevant to the question that was asked. We extract the question, so it's the last message from the chat history. And then we build our response stream, basically the response that will be streamed word by word to the user. So we inject the question as the input to our stream. So the input, as you can see, it was sent as the user message in there. For the context, so basically the documents, we just invoke our retriever components with the question. So that this is actually doing the vector search when we are doing that. And we're just configuring the session ID, so the chat history knows where to save the messages in the history. And then we're transforming the response into a JSON stream that will be sent back to the client UI for display. So while the answer from streaming is happening, what we want to do is also to get basically a context for the chat history. So this is like just another very simple chain where we're using like the second prompt where we're generating, where we say that we want to generate a title for a given chat session. We're just piping the question, and we're saving the title as the context for this chat history session. The chat messages, everything is handled automatically as part of the previous chain. So we just added this part just to check that if a particular chat history session do not have any title, we generate one. And that's basically it. It may sound complex, but in about 100 lines of code, we've generated a full work pipeline that also implements user session history as part of the process. So this is basically what happened when I go to this application and ask any question, like what's the refund policy. Now, just to dive a bit more about like how the history part works. So I've said before, but we have this Cosmos DB NoSQL chat message integration in LangChain. And basically, we retrieve the same component. We instantiate it with optionally user session ID, the user ID. So each session ID is tied to a specific user. Credentials is basically the managed identity that allows us to access to the Azure environment. And then because it's fully integrated into the LangChain ecosystem, we can do just two things. If we pass in the session ID, so that's when we want to retrieve like the full chat message history, we just call get messages and do a bit of transform just to map the human and AI type of messages to follow our a format that suits our front end. So just very simple call in there. And if you want to retrieve like the history of all session, so the one that will be displayed on our history panel on the left, so we have this get all session method, and we pass in just the list of session, we just extract from there the ID and title of the session. So again, very simple method, and just with that, you're able to implement full chat history, getting all the list of the session and all their matching IDs, so you can retrieve the messages after that. So let's see, there's a question. Is the WebSocket that streams the messages back to the browser handled by that library out of the box? So that's a very good question. So to handle the streaming part of the UI, we're using, let me show you the front-end parts because it's also very interesting. So we have this package, Microsoft AI Chat Protocol. So I don't have the link at hand, but if you search for it on NPM, you will have the link. So for this, I'm using an open source protocol. So it's an open protocol that determine how the backend and the front-end parts, so the API and the client in there, communicates together. That includes the streaming part. So that means, so when it's time to do the streaming in the API in there, so I'm showing you how from the front end, I'm calling the backend. So this is the Microsoft, the client protocol from this library. So I'm just telling the API is located in the API URL /API/chat. So where it should call the API. I'm just calling the get stream completion, and basically I will get all the chunks to display from there. So nothing very complicated. Sorry. For the format, I'm using a stream of JSON of JSON objects. So that's what you get in there from the clients. So you can see there that I'm using. It's called new line delimited JSON. So it's just a stream of JSON objects. So one new JSON object every time we have new content for the text. And yeah, you can reuse that in your application if you want. So this was really a quick introduction of how this application works, if you want to give it a go. So yeah, just looking at the chat, if we have more follow-up questions, don't hesitate to ask. Otherwise, I can continue with there. So here, this is the links for all the resources that we've shared, me and Richa, during this session. So you have first the link to the sample that I've just shown you, in case you want to take a look at the code. You have also the documentation from the vector search parts of Cosmos DB that we're using in this sample. We've not implemented semantic cache yet, but we have LangChain components if you want to give it a go. Maybe that's something that we'll add to these samples. We've wanted to keep it simple, not to creep it with too many features, but I think this is something that might be interested. And we also have like all the examples regarding Azure Function. I see one new question. Is the LLM context bound to the documents that were fed into it? Yes, if we go back to the system prompt, you can see that basically we've implemented a pattern that's called escape hatch, saying that, yeah, do not generate answers that don't use the source. If asking a clarifying question to the user won't help, ask the questions. And we should have something that say that if you answer only with information from the sources below. So the sources are the information that are extracted from the vector database, and if there isn't enough information in the source, say that you don't know. So basically, if you try to ask an answer that isn't in the corpus that we sent, so let's try it. This is live demo. Let's try, for example, try to ask who won the last World Cup. Like which country won the last World Cup? So if everything works well, yeah, this is the answer that we should get, just saying, I don't know. You can do anything fancier if you want, but basically just with that part, providing this escape H, we're basically telling the LLM to just focus on the context that we've set using the documents. And yeah, we avoid the use case of having an AI that is maybe too chatty, giving answers to things that it isn't supposed to say. And yeah, I hope this answers the questions. So just something also I wanted to share, if you want to dig a bit more about generative AI. If you're a JavaScript user, we have a full course that's free on creating Gen AI apps using JavaScript and TypeScript. And in that case, that JavaScript is not your cup of tea, you also find links in the repo for other courses using other languages. We have one for Python, of course. We have one also for .NET. And yeah, as you know, you're not alone building all these applications and sometimes struggling. If you want to continue like the discussion about your use case, challenge, or if you have any other question you might have, we have like a Discord channels where you can join thousands of other builders like you. And we also on that channel, so there's a lot of Microsoft advocates. We are regularly connected and discussing on that channel if you want to join. And we also have a space to discuss directly on GitHub. So really don't hesitate to share your question, feedback, and projects there. So yeah, you have all the links in the chat also. And yeah.
Yeah, great.
Johan. In there.
Johan, Richa, you both did such a fantastic job. Thank you so much. I'm going to keep this up for just a second. All these links are in the chat. You can do the scroll back. You should be able to find everything there. I think you've got through almost all the questions. Sorry, Johan. I think you all got through almost all the questions. So I think we're good. If anybody has any more while we're closing things out, you let us know. But let's go ahead, and I want to bring back Askia, so Askia can help close us out, and then we're going to say goodbye. All right, Askia, let's do it.
Right. Well, yeah, thanks to Jay, Richa, and Johan for a great session. I appreciate it. Hopefully you do as well. And we would love to get any feedback that you have on this session today. So we've gone ahead and put the survey link on the screen, and you just want to reference today's event code, which is 25547. That's 25547. Thanks again for joining us.
Thanks, Saskia. And everybody, let's say thank you to our guest today, Johan, Richa. Thank you so much. I wanted to see if you both want to give like kind of a parting piece of like knowledge. Like, what's a thing that you would suggest to developers who've learned here, how they can feel confident getting started? Johan, why don't you give me a quick answer? Like, I'm a developer. I've watched everything you do today. What should I go for first to help me feel the most confident in building one of these apps? Like, is it looking at your documentation? Is it checking out the repo? Is there one particular form of training materials that you suggest?
Yeah, as for me, I learn by doing. So I would say just don't hesitate to grab like any sample you can find, try to run it, try to like decompose it, understand it. And that's basically how I learn myself. So I think this is something that works for many of us, just going through the code, try to run it, understand it. And this is like a good start to build back your very own application, just reusing everything that's built around there.
And Richa, I have one question for you. If I am a new user to Cosmos DB and I'm concerned about cost, is serverless going to be able to help me keep my costs down? Oh, I think Richa, you're having some mic problems. Richa, you there?
Yeah, hello.
Yeah. Okay, here we go. We'll try to get you through this. So question is the same. I'm a new user and I want to make sure that I am staying within my budget. Is serverless going to help me like keep my costs down? Well, I believe the answer is yes. Unfortunately, we're having some technical issues here in Richa, but that's okay. The whole point is to make sure that you're using what you need when you need it. Serverless will give you that, being able to one, reduce the amount of RU that you're going to need because you're just basically using it as you need. That's pretty much the gist of it. Anyway, we are at the end of our time today. And I wanted to say thank you to everyone, to Johan, to Richa, to Askia, and to you, the audience. Thank you all so much for taking part. Make sure that you join us next month. We've got another one of these. And Richa, Johan, I'd love to have you both back, maybe to look a little bit deeper, dive in on something else. Let's keep talking. Well, with that said, let's say goodbye. Let's give everybody a good wave goodbye. We'll see you next time. Thank you for joining us, and have a great rest of your week. Bye-bye.
Yeah.